In this video, I'll show you how to solve the ALEKS problem called determining the volume of base needed to titrate a given mass of acid. Titration problems are just fancy stoichiometry problems, and when you're solving stoichiometry problems, the very first thing you need to do is write a balanced equation for the reaction that's taking place. For my reaction, I have acrylic acid, and the acid is going to vary from one problem to the next on ALEKS. So I have acrylic acid, which is HCH2, CHCO2, and my acid is reacting with the base NaOH. I looked at a lot of different versions of this problem, and it didn't look like ALEKS varied the base at all. Like every version that I saw used NaOH, but if you had KOH, you would be setting this up the same way, or LiOH, or basically any other base, you're going to set it up the same way. Now, for a titration reaction, the products of the reaction really aren't that important. What's important with stoichiometry, what's important is that we know the stoichiometric coefficients between the acid and the base. That's really the most important part. I'm just going to make a note right here. And for a lot of the acids and bases in this particular problem, the stoichiometric coefficient is just 1 for the acid and also 1 for the base. Now, you may notice when you're looking at your problem, after ALEKS gives you the formula for the acid, ALEKS might then say that it is a diprotic acid. That means that it has 2 acidic hydrogens in it. So if you have a diprotic acid, because it has 2 acidic hydrogens, is going to react with 2 molecules of the base, NaOH. And you may also see that ALEKS describes it as a triprotic acid. If you have a triprotic acid, that just means that it has 3 acidic components or 3 acidic hydrogens, which means that each triprotic acid is going to react with 3 molecules of NaOH. So your problem, the one that you're looking at, is going to be one of these 3. ALEKS is either not going to say the word diprotic or triprotic, which means that it's just a 1-to-1 reaction. If ALEKS says that it's diprotic, that means that it's a 1-to-2 reaction. And if ALEKS says it's triprotic, that means it's 1-to-3. And again, if it doesn't use the word diprotic or triprotic, that means that it's just 1-to-1. Now, it is really important that you know the stoichiometric coefficients in order to be able to solve the problem correctly. So this part is an important part for you to figure out which one of these reactions applies to your problem. Once you've decided which reaction applies to your problem, whether it's 1-to-1, 1-to-2, or 1-to-3, the next thing that you need to do is figure out how many moles of acid you have. So step number 1, you're going to be converting your grams of acid into moles of acid, and you're going to do that by using the molecular weight of the acid. So I went ahead and looked up the molecular weight for my acid. ALEKS is going to give you the formula for your acid, so you'll be able to look up your molecular weight as well, or calculate it out, however you like to do it. And you're going to set this up by writing the mass of the acid. My mass is 0.0627 grams, and I'm just going to write acid instead of writing out that whole entire formula. HCH2, blah, blah, blah. Then we want to multiply by a conversion factor that lets us convert into moles of our acid. And we're going to do that using the molecular weight. For mine is 72.06 grams of the acid. And in that step, we're going to be canceling out that mass. Now, in our next step, once we calculate the number of moles of acid we have, the next thing that we're going to do is convert that into moles of base. And this is where we're going to be using these stoichiometric coefficients from whichever one of these equations works for your problem. Since I have a monoprotic acid, not di, not tri, this is the reaction that I'm using. I want moles of acid down on the bottom of this conversion factor so they cancel out. I want moles of base on the top of my conversion factor, and this number right here is going to be whatever the stoichiometric coefficient is for the equation that you're using based on what type of acid you have. So for mine, it's just 1-to-1, but yours may be different. Now, once you have figured out the number of moles of base, the next thing that we're being asked to do is convert that moles of base into volume. So our next step in this conversion process, we're going to go from moles of base into ultimately into milliliters of base. And that step, the relationship between moles and volume, is the molarity of a solution. So my solution is 0.1600 molar, capital M, and that means that I have 0.1600 moles per liter of solution. So this gives me the relationship between moles and volume in terms of in units of liters. So for my next step in this conversion process, I want moles of base down on the bottom because I want that unit to cancel out. I want my volume in liters up on top. I'm going to put a 1 here because it is 1 liter. And so I'm just going to fill in these numbers from this using molarity as a conversion factor. 0.1600 moles of base in every 1 liter of solution. Now this would be the end of the problem if ALEKS was asking me for the volume in liters, but ALEKS is asking me for the volume in units of milliliters. So I need to do one more step where I am converting out of liters into milliliters. Milli is the prefix for 10 to the minus 3. And so we're going to set it up like this. All of this is going to give us our answer in milliliters. 0.0627, my mass, divided by my molecular weight of my acid, multiplied by my stoichiometric coefficient relationship, which for me is just 1, so I'm not going to do anything on the calculator there. I'm going to divide by my molarity, and then I am also going to divide by 10 to the minus 3. And I get an answer of, as long as I plugged everything into my calculator correctly, to 3 significant figures, I get 5.44 milliliters.